Hi everyone, good morning. Let's start. My name is Melamed. I'm Director of AI Products in Toyota Connected Europe. We'll talk about how to build data and AI products in real life. I know there are a lot of sessions today about autonomous driving and so on. Toyota Connected is a little bit different beast. And I will show you a little bit about it, and maybe let's start with a short introduction. What is Toyota Connected? I can do some sounds, but so as you see, Toyota is actually thinking that Toyota will become not only a car manufacturer company, but a mobility company. And for that reason, we are building that future. Cool. Short intro about Toyota Connected. So we're based in London, basically building products for Europe in general, with a very intense activity here in Israel, as you can see, and some reach out to Australia as well. So the concept of the new mobility era, as you can see here, just to scope where Toyota Connected is located in the whole infrastructure and the whole chain of processing in the new era of autonomous vehicles. So clearly every vehicle, you can see here in the bottom, is now connected, right? Every vehicle sends data to the cloud. We're starting today, there are millions of vehicles around the world that are connected and basically sharing variety of data points to our cloud platform. That current state is actually evolving. As we're going into autonomous vehicles, the same vehicles will basically transmit their information to the cloud, but will also get instructions how to move people and how to operate. So all that data, which is actually bidirectional, goes through our Toyota Smart Center facility. But on top of that is actually everything related to cloud, data, and software is managed by Toyota Connected. So our role is to basically get all those vehicles moving, understand their data, and basically create new type of mobility services, whether it is robotaxi, whether it is car sharing, whether it is mobility as a service, you name it. But the thing is that our role is today is to build data-related products with huge amount of data. But that, let's say, product line will become more and more interesting as we evolve into autonomous. So we don't have any role of building AI in the vehicle, but once there will be autonomous vehicle out there, our cloud-based solutions will basically manage all the fleets, demand, utilization, V2X, and so on, everything from our cloud platform. So this is what we are, and this is what we are focusing on. So why we are here in Israel? Specifically, two things. We are looking to collaborations with AI and ML companies. We're currently working with few companies here in Israel in order to bring their products to a global scale. But we're also looking for great people that probably some of you are here in the audience, AI, ML, scientists, architects, and so on. And we have two facilities, one in London, one in Tel Aviv. Both of them are growing fast and building truly amazing products. And you can see here the link. You're welcome to reach out and just explore if something is interesting for you to explore. So for us, specific data science and machine learning and cyber are the foundation of our platform. If you're thinking about it, everything related to the vehicle is evolving in a way that those elements will come from raw data that we currently have to information and to insights. But today we'll talk about how we have a four-stage approach to data and AI products in a real life. Okay, this is what we do today. So clearly you know that we call it, this is like the round circle of product building, right? If you have like a vision, you dream about specific product that you wish to build, and you have like a validation concept, right? How to validate that product might make sense for you to actually build. And clearly there is the build phase, which you're actually coding, we're actually making it work. And then you are basically deploying. And for us in Toyota Connected, we see immediate impact. We see vehicles driving and those products working on top of them. But for us, we understood that the whole concept of creating a long cycle of development for each product doesn't make sense for data products and AI. What it means is that we're trying to implement a new concept of what is coming from the world of design sprints into data sprints. The concept is to start with a vision, right? Everyone starts with a vision. From product side, I always vision new type of products. But the thing is that we're not going into a full building cycle, all right? And we're trying to connect point number 1 and 4 in order to validate and fast any type of business use case that we want to do, okay? How we do that? So clearly when we are visioning, we're trying to envision the output, right? Try to envision the impact, what will be the impact on the business, and to try to envision what will be the effort in order to achieve that. Clearly, everything is related to timeline. We are not, by definition, we are not a research institute, and we are looking to deploy products fast. And that means that in the phase of dreaming, we are starting from a real business use cases, okay? If you have like a taxi operation in a big city that is crunching a lot of trips in a day, how can you make that fleet more efficient? How can you create more revenue for that specific fleet? And everything is based on data. In terms of, again, the problem, is it big enough to solve, okay? And does it align with any type of roadmap that we have as a company and specifically as a data-driven product line? So we'll talk today about simple challenge that I can share. Obviously, not everything is something that I can share. Let's say that you are taking a trip and you're entering your RAV4 somewhere in Texas. Does it make sense for us to predict if a person will stop to fill gas in his current trip? So it's like a relatively simple question to answer, but has a lot of implications in terms of business, in terms of mobility, and so on. Clearly today it starts with petrol, tomorrow with EV, and later on with another type of vehicles. So when we are thinking about the validation process, first of all, we're trying to understand, can we solve this problem? Okay? Do we have enough data? Does it profound and accurate enough? Is it clean enough? And we're trying to do a full spectrum analysis. Okay, so it's not not only about accuracy when it comes to ML. It also has a lot of impact of how a product can scale. We're not building a product to be used by 100 people a day, but a scale of million vehicles each day with millions of trips each day. So that problem of scale is something that is very fundamental in creating a data pipeline and data products. Price. Again, you do wish to have connected services, but pricing for consumer-related product is sensitive. Automotive companies cannot have the burden of creating any type of ML solution without any accurate understanding what might be the pricing in order to deploy it in real life. And what is the value? What is the value for the end customer? What is the value for the fleet? What is the value from the bottom line in terms of revenue in case it is related? And the thing is that we're trying to build a really agile and speedy process in order to gain an answer for that concept. So in this phase, we don't have like a very concrete answer for all those aspects, but we do aim for something that is a little bit vague, but we can definitely say probably yes is a good answer for each of any of those elements. And that's good enough in order to get into the next phase. We're starting usually with a very simple data set. In order to be fast, it can be small, it can be dirty, right? But what we found very efficient is to start with a process of creating those data sets and run them through or using different type of AutoML platforms. We found it very efficient in terms of time and value, right? And effort and overall value. Because in this example, we are collaborating with an Israeli company called Firefly.ai. I don't know if someone is here, no? But they're creating a very intuitive, very powerful AutoML platform. You can think about how to use AutoML moving forward to production, but at this phase, it allows us to validate different type of business use cases and to understand the different feature set that are required for every type of problem. And in order to do that, it allows us also to create a pipeline of products, because some of the products that we will validate very fast in a matter of 2 weeks and so on, maybe 1 week, will allow us to take a product and say, okay, we're not in the right phase for that. Some of the answers are no, some questions are blank, some features and data is missing. Let's push it back in the backlog, right? The concept is to do a quick run on AutoML platforms and to measure and analyze the model performance in a very efficient way, right? And then to have some kind of conclusion. Whether it makes sense to move forward, does it make sense to do another cycle of development? Anyway, it allows us to be more smart or more, let's say, data-driven and be conscious about why we wish to build that product and our ability to have a killer product in the market using that specific methodology that we're using. So just as an example for Firefly, we're using a lot of its outputs, but we usually use very simple visualization tools that are available, like confusion matrix, ROC curve, performance, of course, and model training progress to see how it is being progressed to be finalized. There's a great view of ensemble summary that giving details about the different models and how they are being built. So that gives a very quick, broad view about the different options for building a very accurate model using the data set that are available. So I know that some of the data science that we work with usually have the perception that they know all those answers before starting the work. But you're surprised that it's not the case. Usually, AutoML platform opens the mind of data science and allows them to think outside the box with some different type of features that they didn't thought of, different type of frameworks or algorithms that they thought that might not work. And we believe it's a very efficient way to have a broad discussion about what should be the model implementation method. Just as an example for the different things that we mentioned, as a quick and dirty type of prediction. Again, this is for the example that we mentioned about trip prediction. In this state, you can see how basically the confusion matrix brings quite a very simple way and fast way to understand if the model will actually perform and what will be the accuracy. In addition, you can see the curve, and you see the different scores, right? So the F score and log loss and so on, everything is being very much, very fast and very, I would say, very much simply presented to the data science and the product team in order to get the right insights how to move forward. Specifically about training progress, if we are thinking about this curve, you can see that, in the gray area, you can see that the F score is actually getting pretty much to one specific level. There is no need to do multiple iterations. So you can see that this model specifically give us pretty much consistent results, and we can move forward with understanding that the training doesn't require more time and so on, or data point. One of the things that we thought it's quite powerful is the ensemble functionality. Here there are different types of algorithms being assembled together in order to create one unified model. So in this case, there are 3 types of models running in parallel. Each and every one of them has its own computation time required, different type of memory required, and by the end of the day, it gives some kind of insights about the overall performance of the model. Okay, so if you're thinking about it, again, you're gaining some kind of, the first random forest algorithm gives us, 64%, but in the end, we're getting like 66%. Does it make sense to include additional 2 algorithms to run in parallel in order to gain additional 2%? That's a good question that basically it's very much related to the product performance and where it's supposed to be deployed and how the system overall is supposed to behave in case you have false positives, right? So it's not only about accuracy. If you're thinking about it, the overall, the vision, let's say, to achieve 100% accuracy for a model is great, but sometimes in the real life, it doesn't really make sense. So in this, specific model that we've built, the only concept was just to make sure that we have all the data and make sure that we have the ability to predict and make sure that there are some things some type of algorithm that we should explore, whether it is extra trees or random forest, which makes sense for some of us, but sometimes there are some surprises around here. So going back to the main question, so this tool basically gave us a very quick answer that in a 70% accuracy, we can get to a very good prediction capability. It doesn't mean that this is good to go, right? But it gives us an ability to sense where we want to go next. The validation phase is a little bit more tricky, right? Because we need to have a final conclusion. Is this model accurate enough? Is it scalable enough? And what does it mean from a data set perspective? Do we need to enhance it? Do we need to clean it? Is there a specific ETL functions that need to be in place in order to create efficient pipeline in our model creation and model usage? And do we need to enhance the data? Maybe with additional sources that were not there in the beginning. All those elements basically give us a full cycle of thought and design and implementation, which is relatively fast. The concept is to do it very fast and to finalize the data sets and the problem and the results very very fast. 2 things to consider. Again, accuracy versus speed. If you probably implemented, I think that one of the things that we're trying to achieve again is to have the ability to balance between those 2. And sometimes I think the business side and the engineering side needs to collaborate in order to achieve full understanding what should be reasonably, it makes sense reasonably, in terms of accuracy versus speed. Because again, you don't have ability to run exhaustive processes in the cloud for millions of cars 24, 100 times a day. And it has a cost. That cost also should be quantified in order to understand what might be the cost per vehicle or per driver if you're thinking about, and when comparing it to the lifetime value of that specific feature. Okay? So you cannot build a feature that will generate $1 and create a cloud service that will consume $100 per vehicle. Doesn't make sense. So for us, everything has to be balanced in a way that we will have ability to take those products to actual production. If we take it, let's assume that we have basically moved from that phase, we've validated the product, and now we are saying, okay, we have everything we need, everything makes sense, we can move forward and build it. When we're saying building, sometimes the actual deployments might take roughly up to 20 weeks. Why? I think one of the main issues that most of us as data scientists are building the models in R or in Python, and sometimes the production environment requires Java or some kind of more efficient type of software stack. And those, and the fact that basically this application has to be, the model needs to be integrated into an application and so on, all these processes takes time. What we are trying to build is a more efficient way how to build it. If we're thinking about the question mark in this, let's say, phase of building the models, if in our case we're still debating about whether to AutoML or not to AutoML, and that's the question. What I mean is that for us, using AutoML, different platforms, Firefly and others, we use another platform also, there's a relatively fast time to market in terms of taking the model and using the internal tools of the AutoML in order to create Java and so on, and to deploy it very fast. Okay? But there are some disadvantages, and there are some advantages. Clearly, it's very fast, but in some cases, you don't have full visibility about the code and so on, and the conversion from Python to Java. If you're working in a very regulated environment, as Toyota is, probably, as you probably can understand in Europe, GDPR is the king. And for us, everything related to regulation, the model itself has to be compliant. It means that there are model compliance documentation, there's good understanding what is being implemented, what is the usage of each data point. So building it also requires us to do additional work related to regulation. In some, let's say, models creation, we are also taking a different approach, trying to understand whether we should build personal model or more clustered model, which basically has a lot of impact about how to bring the model into production. That's probably, there's another session to better understand the differences on this one. The thing is that when we went through the process of doing the fast design cycles and validation, we got a very rough result of clearly 70% or something like that. But when understanding all the features, when understanding the impact of each feature, and when understanding how to clean the data, where is the sensitivity of the model, and how much time does it take to compute each model in the ensemble functionality, it got us to a better understanding of what should be built and how. And specifically, it allowed us to move away from the AutoML platform and to build the overall model using our own methods, specifically TensorFlow and others, but again, with random forest, but with more focused and with very clear eyesight what we wish to build. And that basically gave us the ability to create the model with prediction score of 97% currently. And the whole concept is just to share with you, again, again, most of the models that we are building is not going into production. As you probably from the previous slide, 90% are actually don't make it to production. And the thing is that when you have more clarity about why those models failed, you have the ability to implement that knowledge back into your design process and get higher success rate of pushing and getting models more accurate into the production line. Clearly, when we are deploying, and for us, when we deploy, we can see immediate feedback, whether we have any type of analytics that is running, like a real-world analytics allows us to understand how the model performs in many ways in real life. Again, it's not training, it's not testing, it's like a real-life analytics. And that's the real criteria that we are taking into consideration moving forward. Drifts is something that we experience with every model. And because things are basically, change, right? Everything changes. Data changes, noise, different type of garbage. Everything is, those systems are almost dynamic, and the ability to monitor the drifts is very critical. So we need to be on top of stuff and to iterate. All those needs to be adapted as we move forward. We're trying to analyze drift and analytics, to analyze all those signals, what might be the right timing for us to update the model. And sometimes it's continuous, but sometimes it's according to specific changes. And again, to support continuous deployment, those systems, once in production, they cannot stop, right? So the commitment is there because the business requires that type of commitment. That's it from my side. If you have any questions, if you want to explore the jobs portal, whether it is here in Israel. Yes, so I think that one of the things that we understood that it will be more efficient, let's say, to drop some of the ensemble algorithms that were part of the suggested path to move forward. And also the fact that when we explored the code that AutoML created, we had the ability to understand, okay, some of the data points that are available over there are basically not something that is really have a real impact about the model performance. It actually gave us the ability to say, okay, those are a little bit junky, but let's put more quality type of features inside that can basically represent the same element of the user or the driver and so on. So by getting into the code and into the output of the AutoML, basically it allowed us to get a full understanding. And at this point, it was basically, they can take two paths, by the way. But sometimes when your engineers are taking a look at the feature set and take a look at the challenge and understand the code that they got from the AutoML platform as a reference, they say, okay, I can do that better sometimes. And that's like a decision point that we are moving forward with this. No, currently no deep learning, yeah. Because, specifically from our side, number of layers is not a critical factor at this point, but I think that, maybe as we move forward, it will become, but right now, no. Yep. Yeah.